In this video, we're going to do some more dosage calculation problems for those nursing students that are out there. All right, in this first one, the nurse is supposed to administer 30 milligrams, which you can see right here. All right, and the medicine, the vial, contains 40 milligrams per milliliter. What is the correct dose? All right, so basically we're going to take what is ordered and multiply by what is available. So we're going to take a look at the medicine that was ordered, and in this case it was 30 milligrams. So I'm going to do 30 milligrams and put that over 1. All right, then I'm going to multiply by what's available. And the medicine is available as 40 milligrams per milliliter. So when I do the multiplication, I've got to choose where I'm going to put the milligrams. I want the milligrams in the bottom so that I can use the unit analysis and cross off those labels of milligrams. So I'm going to put 40 milligrams in the bottom. I'm going to put the milliliters in the top. All right, from there, we can, using unit analysis, say, okay, here's milligrams, I'm going to cross it off. All right, the only label that is left in the problem now is milliliters. All right, what is the correct dose to administer? You will be administering milliliters of this, so you would multiply straight across the top, which is going to give you a 30 milliliters. And then on the bottom, 40 times 1 is going to give you 40. You'll take a calculator and divide that out, or just know in your head you could cross off those zeros. 3/4 is going to be 0.75, so we will write it as 0.75 and milliliters because that is the only label left in the problem. In this example, again, it's going to be a pretty straightforward dosage calculation problem. We're going to basically take what has been ordered and multiply it by what is available. All right, so we can see here that 500 milligrams have been what is ordered. All right, the label on the bottle reads 250 milligrams per 5 milliliters. So I am going to start with what has been ordered. I'm going to choose to write that as a fraction over 1 so that I can use this unit analysis. So I'm going to put that 500 milligrams over 1. We're going to multiply it by what is available. We'll label this available. We'll come back up to the story problem. We'll see what that is. It is available as 250 milligrams per 5 milliliters. All right, now how much of the suspension should the nurse administer? That would be milliliters. How much? A liquid. All right, which means from what's available here, I have to make a choice. How am I going to place that conversion factor? I'm going to put the milligrams on the bottom so that the milligrams cross out. That'll put my only label left as 5 milligrams in the top. So I'm going to put the 250 milligrams in the bottom. I'm going to put the 5 milliliters in the top. All right, labels in top and bottom can be crossed out, which is what we want to happen. Looking now at the problem, the only thing you see is the milliliters, which would give us how much, how many milliliters. So I'm going to multiply straight across the top. That 500 times 5 is going to be 2,500 with the label of milliliters. Multiplying across the bottom, 250 times 1 will just give us 250. All right, a quick grab of a calculator here. You can take 2,500 divided by 250, or you can do this probably pretty much in your head. Cross those zeros off, 250 divided by 25. That's going to be a nice little 10 milliliters. All right, and it will be per dose. So every time that you give this medicine, it would be 10 milliliters per dose. Okay, for our third example here, again, we like that process of taking what is ordered and multiplying by what is available. All right, so the client's supposed to be given 1 gram, all right, daily. And then if you take a look at what is available, how the medicine comes, it comes in 250 milligrams. All right, so our just taking an ordered times what's available is not going to work in this scenario because we're going to have grams on the top and milligrams on the bottom, and they're not going to match, so they're not going to cross out. All right, so I had earlier done videos that indicated how you could quickly convert within the metric system. All right, so I just have already written out the chart. All right, but above here I've got the mnemonic that's going to help you remember that. Kittens hate dogs because dogs can't meow. All right, so saying that and then taking a look at those first letters there, we've got kilo, hecto, deca, our base unit, which would be our grams, and our liters and our meters, deci, centa, and milli. All right, so just a quick way there to look at those metric prefixes written from largest to smallest. All right, my goal here, I need 1 gram converted into milligrams. All right, the 1 gram is the base unit. So my base unit is right here. So I am starting at that base unit and I'm going to go to milligrams. So I'm going to hop 1, 2, 3 hops to the right. If I go 3 hops to the right in the chart, then when I do the 1 gram, the decimal point is at the end and I'm going to go 3 hops to the right. So then that's going to give me 1,000 milligrams. All right, now, of course, you can multiply and divide by powers of 10 when you are converting within the metric system, but converting within the metric system simply means moving the decimal to the left or to the right. So a chart like this works really nice. All right, now that I know that the client is to be given 1 gram or 1,000 milligrams, I can go to the ordered times available. Okay, so what is ordered is 1,000 milligrams. I'm going to put it over 1. Then I'm going to choose to multiply that by what is available, which is my 250 milligram tablets. All right, now again, I want the milligrams to cross out. So since they're 250 milligram tablets, the way I'm going to write this is I'm going to put that 250 milligrams on the bottom, and then for a label I'm going to say 1 tablet. All right, that way when I cross my milligrams and milligrams out, I still do have a label. All right, how much will the nurse give? It's going to be in tablets, so I'm going to take 1,000 times 1, multiply straight across the top. So I'm going to write it down here. I will have 1,000, and then we'll have tablets over 250. And doing a simple division here, you're going to see that that's going to end up then being 4 tablets. All right, so on this one, yes, we still were able to use that what is ordered times what is available, but first had to do a little bit of converting within the metric system in order for this unit analysis to actually work out. All right, in this dosage calculation question, we're going to really emphasize the difference between per dose and per day. The question is asking for what is the maximum amount of tablets that the client can have in a day. So this is the per day dosage. So this is going to involve a 2-step process. All right, now we're still going to go with that, taking what is ordered and multiplying by what's available. That's going to be our step 1. So let's outline here our step 1. We are going to take what was ordered. So we're going to set the problem up here as ordered. We'll come up here. A nurse is preparing to administer Tylenol, 650 milligrams every 6 hours, PRN. Okay, so what was ordered is the 650 milligrams. And then we're going to go over 1 so that we've got a fraction. All right, we're going to multiply that by what was available. Okay, so what's available? The amount available is 325 milligrams per tablet. So again, we want to set this up in a way so that our milligrams are going to cross out. That means I'm going to need to put the 325 milligrams in the bottom, and then I'm going to go ahead and actually label it 1 tablet in the top. That way we are going to have a label here. Our milligrams and milligrams cross out. So then when I get done right here, I'm going to have how many tablets, all right, every 6 hours. So the dosage. So I'm going to multiply straight across the top. We'll get 650, and then I'll go ahead and put tablets on here. Multiplying across the bottom, 1 times 325, 325. So if we go ahead and divide 650 by 325, we get 2 tablets, all right, and then every 6 hours. So that's the dose per dose. But the question is, what is the maximum amount of tablets the patient can have in a day, so in an entire day? So now we're going to have to take a look at a step 2. All right, in a day, there is 24 hours in a day. So I'm going to have to consider 24 hours in a day and consider the dosage that is given. So we're going to call this hours in a day. This is going to be your conversion factor. Okay, so we all know there's 24 hours in one day. So I'm going to go ahead and set up 24 hours, all right, in one day. So that's a conversion factor, something that is equivalent that we know is true. Okay, now I'm going to be multiplying this by the dosage that is going to be given. So let's call this dosage given. And our dosage given is going to be 2 tablets every 6 hours. All right, now how do I want to set this up? I want these hours to cross off, so I want the 6 hours in the bottom, and then I want the 2 tablets in the top. Okay, that is then going to allow me to cross off hours and hours. Our label then is going to give us what we want. We want to know how many tablets in a day. I have tablets per day left over. So I'm going to multiply straight across the top. That's going to give me a 48 tablets on the top. And then 6 times 1 there on the bottom is going to give me a 6. I'll have a label of day. Going ahead and dividing that out, 48 divided by 6 is going to give me 8. And then using that label, it's going to be tablets per day, which was the ultimate answer to the question. All right, so 8 tablets per day. So we definitely have a per dose calculation here, and then comparing that to the per day calculation. Okay, in this dosage calculation question, it can be done a couple of different ways. I think what I'm going to do is I'm going to use the unit analysis all the way through for every type of calculation that's got to be done in order to be able to actually answer this question. All right, and I also think let's take a little different approach. Let's go through, and as we read the story problem, let's highlight important pieces of information, because that's also a nice skill to do when you're trying to do dosage calculation problems, or really any type of story problem. All right, so we've got a nurse that's preparing to administer amoxicillin, 40 milligrams per kilogram per day, divided equally over 12 hours. Okay, so what is being administered here is the 40 milligrams per kilogram per day, all right, divided equally every 12 hours. Okay, so let's just go ahead and kind of put that all together. All right, another piece of important information, it says to a toddler who weighs 33 pounds. All right, so there's our 33 pounds. All right, available is amoxicillin, 200 milligrams per our suspension here. So available, 200 milligrams per 5 milliliters. Okay, question then is going to ask for how many milliliters should the nurse administer per dose. All right, so we're actually going to have to go through, we're going to have to, since this is kilograms and this is pounds, we're going to do a simple conversion there first. That will be step 1 to get these pounds in kilograms. Then we're going to calculate milliliters per day. All right, since this is going to be divided equally every 12 hours, okay, we're going to do a per day dosage. And then we're going to get our per dose. What has to be, how many milliliters per dose. All right, so step 1, even on the conversion here from pounds to kilograms, I'm just going to go ahead and show it as a unit analysis as well. So we're going to have our 33 pounds, and we need that converted to kilograms. You do have to have memorized that 1 kilogram is equal to 2.2 pounds. All right, I'm going to automatically line those pounds up so that I've got pounds in the top and pounds in the bottom. That's going to show us that basically all we had to do was take 33 divided by the 2.2. So we'll have 33 kilograms divided by that 2.2. And there again, on that, you don't have to do unit analysis there, when you divide that, that comes out to a nice little 15 kilograms. Okay, so that's going to be the patient's weight in kilograms. But some of you are just going to automatically know that you're supposed to take 33 divided by that 2.2 to convert it to kilograms, and that's okay too. All right, now for our step 2, all right, we're going to calculate the milliliters per day. So let's actually just write that down. Milliliters per day is what we're going to be calculating here. Now, again, what is ordered times what is available works really nice. All right, so I'm going to take what's ordered. All right, we'll go back up. We're supposed to administer 40 milligrams per kilogram per day. So the way I'm going to choose to write that is I'm going to go ahead and put the 40 milligrams in the top, and then I'm going to do the kilograms per day in the bottom. Okay, just so that we know that this is going to give us milliliters per day when we're all done. All right, now I need to multiply that by what's available. So we're going to label that available. Okay, we said available is 200 milligrams per 5 milliliters. Again, we want those milligrams to cross out, so I'm going to put that 200 milligrams on the bottom, and I'm going to put the 5 milliliters on the top. So now we're going to take the milligrams and cross out. Now, if I stop and look at my labels, I'm trying to get milliliters per day, but I'm going to have milliliters per kilograms per day. All right, so that means I'm not done. I have to choose to multiply by another conversion factor, and I'm going to include the weight because I need that kilograms to cross out. Okay, so I am going to include the patient's weight now. And 15 kilograms is on the bottom here, so I'm going to do my 15 kilograms on the top and then over 1. That's then going to allow me to cross out the kilograms and the kilograms. So now I will have milliliters per day left over when I do this. All right, we're going to multiply straight across the top. When we multiply straight across the top there, we'll get 3,000 with our label of milliliters. Multiplying straight across the bottom, I'm just going to have a nice little 200. You're going to divide 3,000 by 200. There you will have 15 milliliters per day. Okay, now we needed that because we're going to use that 15 milliliters per day to figure out how many milliliters per dose that we're going to give. Now, I'm going to go ahead and use unit analysis again on this third step. You wouldn't have to use unit analysis on this third step, okay, but just to stick with the pattern of the unit analysis, I am going to go ahead and do it that way. All right, now I need per dose here, and this is per day, so I'm going to have some conversions in here. I need to get rid of the day. All right, so I'm going to say hours in a day and write down a conversion factor, hours in a day. All right, we know how many hours are in a day. There are 24 hours in a day, so I'm just going to say 1 day over 24 hours. Okay, now I'm going to multiply by how often the dose is given. All right, so up here at the beginning, we're supposed to administer 40 milligrams per kilogram per day, divided equally every 12 hours. All right, so one dose is being given every 12 hours. So here I'm going to say how often dose is given. All right, and we said 1 dose is given for every 12 hours. All right, over here, hours is on the bottom. I've got 12 hours, so I want the 12 hours to be on top so that the hours cross out. So 12 hours on top, and that's going to be 1 dose. I'm giving 1 dose every 12 hours. Okay, so what's that going to allow me to do? That's going to allow me to cross off hours and hours at this point. Okay, now I still have day and dose. All right, I want to know milliliters per dose. So then that means I'm going to have to multiply again. This time I'm going to multiply by the dosage that is given. So let's label this dosage given. and it's 15 milliliters per day. All right, well, the thing that I need to cross out is the per day part. So my day is going to go on the bottom, per day. 15 milliliters is going to go in the top. That's going to let me cross out now days with days. So then taking a look at your labels, you've got milliliters per dose. It's the only labels that are left. So now we know we're done. We don't have to multiply by anything else. Multiplying straight across, we'll have that 180 milliliters. Multiplying straight across the bottom, we'll have 24, and then we've got the label of dose. So going ahead and dividing that, 180 divided by 24, that's going to give me 7.5 milliliters per dose. All right, so like I said, this is not the only way to do it. You would not have to do unit analysis here. I mean, you can do some reasoning skills, all right, and just know that you're supposed to divide that by 2 because you're giving it every 12 hours. There's 24 hours in a day. But for those of you that are really liking the unit analysis process, because you cross out labels, whatever label is left, that's the label of your answer, so it's real easy to tell when you're done, all right? This is the best way to do that if you like that unit analysis. Okay, this is yet another type of dosage calculation type of problem. You're just calculating an input and output record for a patient to find out how much they've consumed and how much outtake there is as well. Now, this question wants the nurse should record how many milliliters of intake on the client's record. So we're just going to be worried about what the intake is here. All right, now if you start and look at what you've got here, you've got ounces of orange juice, you got a cup, which again is in the same system, so we can convert that to ounces. We've got ounces of water. We also have milliliters of ice, milliliters in the IV, and then back to cups. So what I would do is probably go through and find all of the ounces, all right, because our answer has to be in milliliters. So we're going to add up all of our ounces, convert our ounces to milliliters, add up how many milliliters are already in the problem, and then we'll have our total here. So I'm going to highlight here, we've got 4 ounces of the juice, we've got 1 cup, which again is going to be ounces, because we're going to do ounces in a cup, okay? 3 ounces of water. We don't want the milliliters. We don't need that milliliters. We've got 1 cup of broth. Okay, so as far as our ounces goes, so let's kind of do this in steps. All right, so step 1, all right, how many total ounces do we have here? Okay, so we're going to use our 4 ounces. We're going to add that to 1 cup. Now, you do have to have memorized that 1 cup equals 8 ounces. Okay, so I'm really going to add 8 ounces there, something that you have to have memorized. Then we've got the 3 ounces of the water, and then we've got another 1 cup, but we're not going to add 1, we're going to add 8 because there's 8 ounces in a cup. All right, so then that's just going to be add 4, 8, 3, and 8. When we add all that up, we get 23 ounces. Okay, now since it is asking for milliliters, then our second step here is going to be able to convert ounces to milliliters. So step 2, we can do that. Again, some of you are just going to know that you're supposed to multiply, all right, but if you don't, you can use the unit analysis, which we have been using all along. You do have to have memorized that 1 ounce is equal to 30 milliliters. Okay, that has to be memorized either way, whether you use unit analysis or not, because I've got to be able to get my answer here in milliliters. All right, so yes, multiplying those two numbers will give you your number of milliliters. If you want to see it done as unit analysis, I'm going to take the 23 ounces over 1, multiply it by the conversion factor, putting the ounces on the bottom. So 1 ounce here, and then 30 milliliters on top. All right, that's going to allow ounces and ounces to cross out, and then that's showing that yes, we would multiply 23 times 30. That's going to give us then 690 milliliters. Okay, so then we will keep that. There's our milliliters. Okay, now we're going to go back up and see how many milliliters we have here in the story problem. All right, now this 100 milliliters All right, it's a 100 milliliter, and then I'm going to do the whole thing. Cup of ice chips. All right, ice chips are not a liquid. Ice chips are a solid. All right, so again, something else that you need to think about. All right, that 100 milliliters, you're not going to add 100. You're going to add half because it's ice chips and its volume when it melts and turns to water. Okay, where it's going to be different than 100. So it's always half on your ice chips. Okay, so step 3 here. I've got 100 milliliters of the ice chips, but we're going to use, and let's put use 50 milliliters, okay, because we said it's half and it's a volume. Now let's finish reading. IV bolus here, 150 milliliters there. So then we will add in our 150 milliliters. From that, I can just add those two, 150 and 50. Remember, we're using 50, not the 100. So then that's going to give us 200 milliliters from the two things that are in the story problem. So I'm going to go ahead and highlight that. Last step then would be to add up all of our milliliters. So as a final step, just final total. All right, so we'll just have total here. It's going to be the 690 milliliters that we got from converting our ounces to milliliters, plus the 200 milliliters that we got from the milliliters in the story problem. That's going to give us a total of 890 milliliters total there for the intake. All right, and I would just venture to say on a problem like this, it is straightforward. You're just adding everything up. So the sticking point, or the point that will make you miss it, is on the 100 milliliters of the cup of ice chips. You're going to forget, and you're going to accidentally add in 100 instead of using the 50. Okay, in this dosage calculation problem, I definitely want to include one of these because, as you can see right here, I have a microgram measurement and a milligram. Okay, so we earlier in the video and earlier in my lectures, we have used a chart for our metric conversion, so we could just hop left, hop right in the chart and convert really easily. Okay, microgram is not in that chart, so I'm going to work this problem out using unit analysis, but then having a conversion factor memorized for the microgram, which you are going to need if you encounter that. All right, so let's go ahead and look here and see what we've got. All right, so we're supposed to administer 12 micrograms per kilogram, all right, of an IV one time for a person that weighs 175 pounds. All right, so right off the bat, I've got pounds, I know I've got kilograms, so I know I'm going to have to do a conversion there. All right, available, all right, so available is 0.1 milligrams per milliliter. All right, the question is asking how many milliliters will the nurse administer per dose, round to the nearest tenth. Okay, so again, we'll do this in steps. Obviously, we've got pounds here, we've got kilograms here, so we've got to know what the patient weighs in kilograms. Unit analysis works, but you can also, again, just divide. I'll go ahead and show the unit analysis for anybody that likes to do it that way. There's 175 pounds for the patient over 1. We're going to multiply by the fact that we know that 1 kilogram is 2.2 pounds. All right, I chose to put the 2.2 pounds on the bottom again, because if we're doing this unit analysis, our labels top and bottom have to cross out. Would have been just a simple calculation of a 175 divided by that 2.2 to get the final answer. This person then is going to weigh 79.5 kilograms. Okay, so we will use that. All right, now our step 2 is going to be our unit analysis, and we are going to then just be able to do this in 2 steps with a complete unit analysis here. Now, I did say we've got to deal with this micrograms versus milligrams. I'm going to have a conversion in there. I can't use the hop left, hop right in the chart that I have been demonstrating in my other videos and earlier in this video. So you're going to need to know the conversion factor. So I'm going to write it out here. 1 milligram is equal to 1,000 micrograms. All right, so you just have to have that one memorized, because the chart process, hopping left and right, the way I've showed it earlier, does not work. All right, now, as with everything, we usually start with what is ordered and multiply by what is available. So what was ordered, all right, is the 12 milligrams per kilogram. All right, so I'm just going to go ahead and put that, oh, I'm sorry, micrograms, 12 micrograms, all right, over kilograms. So then we'll just go ahead and line that up, start that up that way. Okay, we are going to then multiply by what is available. We'll label this available. We'll come back up and look here, and available 0.1 milligrams per milliliter. Okay, now none of these labels are going to match. Like, I've been lining it up so that opposite spots can cross out. All right, but I don't have anything to label, so in this case it really doesn't matter. I can do the 0.01 milligrams per milliliters on top. I could, as it's written, I could do milliliters on top. I could do the 0.1 milligrams on the bottom. At this point, it really doesn't matter how I put this one in because nothing crosses off yet. So I could write this any way I wanted. Okay, now that doesn't help me. I need milliliters, okay, per dose here to get off. So I've got a lot of things I've got to get rid of. I've got to get rid of the kilograms. I got to get rid of the milligrams. I got to get rid of the micrograms. So one thing at a time. All right, we have a conversion factor that's got both of these things in it. Okay, milligrams on the bottom, micrograms on the top. Okay, so then let's put these so that they will cross out. We'll put milligrams on the top and micrograms on the bottom when I add this. All right, let's go ahead and put it in red. All right, so my conversion factor, I'm just going to say CF there for my conversion factor. I want the 1 milligram in top, so those two will cross out. I want the 1,000 micrograms on the bottom, so these will cross out. Okay, so we'll cross out and kind of color code this. The micrograms and micrograms cross out, so that takes care of those two labels. All right, and the milligrams and milligrams cross out. So with one conversion factor there, I got rid of a lot of labels. Now I'm down to milliliters per kilogram. That's not what it asked for. It only wants milliliters. So I got to get rid of kilograms. Well, to get rid of kilograms, then that means I need to multiply by the patient's weight. So I also have to include that. My kilograms is on the bottom here. So I'm going to put the 79.5 kilograms on the top, put it over 1. Then that's going to allow me to take kilograms and kilograms out. Okay, as I've said, looking at your labels, that'll tell you when you're done. How many milliliters? The only label I have left is milliliters, so now I do know that I am done. So multiplying straight across the top there, I'm going to have a 954 milliliters. Multiplying straight across the bottom here, 1,000 times that 0.1 is going to give me 100. All right, and then straight division here. Now, it did say round to the nearest tenth. All right, so this would be 9.54 if I just divide out normal, rounding to the nearest tenth. That's going to give me a 9.5, and then that's going to be milliliters per dose. Okay, so taking that rounding into consideration there at the end. All right, so definitely an example here with the microgram and needing to know that conversion factor, since the hopping left and hopping right in the cute little chart that I had used earlier is not going to work for that. Okay, in this last example here, I would like to do this without using the mnemonic for converting within the metric system, hopping left and hopping right with the decimal, because you do not have to do that. You can just use conversion factors and do unit analysis for the entire thing. So definitely this problem can be done more than one way. I'm just going to show it all with unit analysis. But what I'm talking about here is I've got milligrams per kilogram here. We've got grams per milliliter here. All right, so those two things are not the same. Now, before I started, if I wanted, I could use the chart where I'm hopping the decimal left or hopping the decimal right in order to convert. I could easily convert that 0.2 grams to milligrams and then just use a simple two-step process for my, well, three including the weight, but three conversion factors for the unit analysis. Or I can maybe read the question, not really realize that there's going to be an issue with this, and then just do the whole entire thing using unit analysis. So that's what I'm going to do. Let's go ahead and go through and outline the problem, what's available, what's administered, what needs to be ordered, that sort of thing. Do some highlighting of information, because that is another skill when you're doing story problems here. So we're supposed to administer 1.25 milligrams per kilogram. Okay. Then it says for a client who weighs 183 pounds. All right, so there's some more important information. And the medicine is available as the 0.2 grams per milliliter. Okay, so how many milliliters will the nurse administer? Just straightforward, how many will he administer? Okay, so again, kilograms, pounds, you've got to do that conversion. You may use unit analysis, or at this point, hopefully we're really good at, we realize that we're just supposed to divide by 2.2. Okay, so regardless of how you choose to do that, your step one is to get that 183 pounds into kilograms. So I'm going to go ahead and show that unit analysis. We know that 1 kilogram is 2.2 pounds. All right, just kind of showing the work there. You don't need to go to all this work, because at this point you probably have it memorized that you take pounds and divide by 2.2 to get your kilograms. So then I would have 183 kilograms on top. I'd have the 2.2 on the bottom. Dividing that out, we're going to have 83.2 kilograms. All right, so that is our patient's weight. All right, now we're going to do our unit analysis. And we're going to start, like we have many, many times. Let's take what is ordered and multiply by what's available, because that's always a good place to start. So I'm going to take what's ordered. All right, and what was ordered was the 1.25 milligrams per kilogram. All right, so we'll have 1.25 milligrams per kilogram. All right, going to multiply that by what is available. All right, up here in the story problem, what's available? The 0.2 grams per milliliter. All right, now it is at this point that you realize if you write down grams and milliliters, none of the labels are going to match. All right, so that's okay. That just means that you're going to have to include some additional conversion factors. Okay, so let's go ahead and write it. And again, it really doesn't matter which one I put where, except I'm going to choose milliliters on top, because why? How many milliliters will the nurse administer? I want milliliters ultimately, so I'm going to go ahead and put that milliliters on the top and the 0.2 grams on the bottom. But at this point, I still can't calculate, get anything crossed out. So I don't have to convert by hopping left or right if I know that, here, let's write it in red and let's put it over here. If I know that 1 gram equals 1,000 milligrams, all right, without using the chart, if I just happen to know that that's a conversion factor, 1 gram is 1,000 milligrams, okay, now I have, with this conversion factor, I have both grams and milligrams. Here's grams and milligrams. If I place this appropriately, both sets of labels are going to cross out. All right, so let's go ahead and multiply by my conversion factor here. Grams is on the bottom, so I need grams on top. So I'm going to choose to put the 1 gram on the top. I'm going to choose to put the 1,000 milligrams on the bottom. Now, what's that going to let me do? That's going to let me get rid of grams and grams. All right, and in the same step, here's milligrams and milligrams. So by multiplying by that conversion factor, I got rid of 2 labels all at once. I am now left with milliliters per kilogram, but the question says how many milliliters. I don't need the kilograms. I need to not have that, not include it. So the only way to get rid of it would be to multiply by the patient's weight. So I do have to include the weight. We did the converting to kilograms. Kilograms is on the bottom here, so I'm going to put the 83.2 kilograms on the top over 1. That'll allow me to do my last crossing out. Let's go ahead and use red here, kilograms and kilograms. Okay, now I check my labels. All my labels are gone except for milliliters, and that's what the question asks for, how many milliliters. So when I multiply straight across the top there, I'm going to get 104 milliliters. Multiply straight across the bottom here, I'm going to have that 1,000 times 0.2. That's going to give me a 200. When I divide that out, I'm going to get 0.52 milliliters. All right, question asked for how many milliliters. So again, this question can be done more than one way. You could convert this to milligrams before you even started by using the chart that I had done earlier in this video and in other videos as well. So hopping that decimal works. That way you don't have to have this memorized. You wouldn't be using this.